Hello, and welcome to the first class of Finance 3120. We are working in the Notebook 1.1 Introduction to Python. So this is our Jupyter Notebook, and really quick overview. Here's a Jupyter Notebook where at the top it has the ability to rename by simply clicking on the title. Under File, we can save. We can also save by clicking the disk. Moving to the right, we have a run and a stop. And then down here, we have some code and some writing, which we'll discuss. In the first two lines, or the first two sections, you notice there's no gray background. Also notice that right here, when we're selecting either of these, the word markdown appears. What this means is that it gives us the ability to write out text that Python does not view as code. It won't try and execute it. Coming down a little bit further, we have a gray cell, and this is our first cell of code. If we were to click here, notice it now says code. So now we're looking at code, or code is what Python will execute, and you can tell it is code, again, by the gray or by the word code at the top. So getting into this a little bit, what we have is getting started with Python. We're going to discuss everything there is, the basics of Python, how do we write some code, how do we execute code, how do we do all different kinds of things. So typically what happens is the first bit of code somebody will write is hello world. I've modified that a little bit to just say hello world, welcome to class. And you can see we've written this. It's in the gray box, so we know it's code. And it is text. I want it to display, so I've wrapped it in quotes. You can see those here. Whether they be single or double quotes is up to you. Just make sure you're consistent. In other words, don't start with a single and end with a double, or start with a double and end with a single. If you've got a single quote to start, end with a single quote. If you've got a double quote to start, end with a double quote. But we can then run this cell. And the first way to run it is just to click the run button. And there we have it. You notice here it says in one, out one. And what this means is this is the first line of code that we have submitted to our notebook. And this is the output for line one. So if we were to click back up here, notice that if we run it again, it goes to number 2. And what this means is now this is the second line we've submitted, and it'll keep counting up as long as we keep running it. Another thing worth knowing is that in addition to running cells by clicking run, we're going to go over a few different shortcuts, ways to make your life quicker so you can do things with a few keystrokes. So the first one we have here is escape plus A. So when we hit escape, watch what happens. Right now it's currently green. If we hit escape, it becomes blue. So now we can hit A to insert a cell above, an empty one. If we come back down here, if we hit escape, turn it blue, and hit B, we insert a cell below. And you can keep hitting B as many times as you would like. If we want to delete these cells, select a cell, hit escape, turn it blue, hit the letter X. You can keep hitting X in all those extra cells we've made. A few other things, Alt or Option Enter will run a cell and insert a new blank one for you. Control S or Command S if you're on a Mac will save your code. A few other things. If we want to run code just very quickly, it's not even in here. Oh, I'm sorry, it is in here. And this is how I will run code all the time, is hold Shift and Enter. And watch that number 3 will go to a 4. So rather than clicking around, you can just hit Shift Enter. Notice here, the next thing is the use of a hash makes comments in your code. And we'll see this later on. This is very important. It's something you're going to do quite a bit of as you write code. We don't have any yet, but you'll see that down here when we get to these cells. So those are just a few of the basic cheat sheets or keyboard shortcuts to make your life easier. So let's start writing some more code. Let's look at Python as a calculator, just some very basic stuff before we get into any finance related things. And one of the most basic functions of Python is to use it as a calculator. It will do math just like a calculator would. So first thing you see down here in the code cell is that hash followed by the word addition. What this indicates to us and to Python is that this is a comment. This is not something that should be executed as code. And if we were to actually remove that hash, notice how it is now standard font that is black. When we add that hash, it becomes green and is now in italics. So this is, again, a comment. It means this is for the reader, the programmer, somebody, some human's ability to understand what is trying to be accomplished, right? It's very easy when we see 5 plus 3. It is clearly addition. So maybe adding the word addition above isn't that helpful, but it gives you an idea of how you set up code. So again, let's run this. And I'm going to use the Shift Enter so you won't see my mouse move. And what we should hopefully find is that 5 plus 3 is addition, as it says, and it will give us an output of 8. And that is, in fact, exactly what we find. And we can do many other basic math functions. So subtraction, 5 minus 3 is 2. Division, 5 divided by 3 is 1.67. Multiplication, 5 times 3, 15. And what you may not have seen before is this modulo. And it also is known as just simply getting you the remainder from division. So 5 modulo 3, and if you cannot tell, this is a percent sign. If we run this, we get a 2. Right? 5 divided by 3 goes in one time, you have a remainder of 2. So continuing on, we have some other things that are worth pointing out. What we have here is integer division, which is a little bit different than something you have seen probably before, and it is 2 division lines. So obviously integer division itself isn't unique or exciting, but having it be written as 2 division lines may be something you haven't seen before. And that's going to give us the full integer with no decimals. In other words, for getting the remainder like modulo gave us, now we're getting the other side of that. We can have composite expressions where we have more than one expression in a line. So we don't just have to limit it to one like we've done above. So 5 plus 3 minus 2 plus 7 will give us the answer of 13. And notice in the above example, we did just simply move left to right because they're all the same order of operations. However, when we do this and we have different order of operations, now we're including a multiplication sign, we should now no longer move from left to right. It will follow that order. So in other words, we will have 5 plus 6 minus 7. So 5 plus 6, 11 minus 7 should be 4. And that is exactly what we get. We can use brackets or parentheses. So now we will enforce that addition first because of the parentheses, and it'll be 8 times -5, -40. And we can negate a value. So this would be 8, throw a negative sign in front, and we're left with -8. So continuing on to this next section, we have floating point expressions. And the current examples that have been performed above, they're on integers, they yield integers, but that does not mean that Python can only use integers. So let's look at a couple of examples. First, we have floating point addition. So 5.0 plus 3 still gives us 8, but notice now there is a decimal there. So if we needed to enforce having some type of decimal in our answer, we can do that. Same with multiplication, exponentiation, raising something to a power. You can do that with 2 multiplication signs. And you can see how that works with remaining or retaining that decimal. So up to this point, we've just known what these are by looking at them. We've known we have an integer, or we know we have some decimals, and that turns out to be a float. We can utilize Python to very quickly and easily check data types as well. So if we weren't sure, by typing the word out, type, and putting in a value between its parentheses, we can get back what type of data that particular value is. So type 5 is going to be an integer. Type 5.0 is going to be a float. Type 5.0 to the 3rd power is also going to be a float. So we can pass in any different types of data, and it will tell us what type we're getting out. So as it says here, this is a built-in function. So we're going to pass an argument to a function type of x, and we get an output. I will say that during this lecture and all future lectures, you're going to have some notes that I've put into the comments or into the code itself or the notebooks I will maybe address some of them, others I'll just skip over. It's your job to read through them. What I'm really here to do is to talk through all the code and talk through what's happening behind the scenes. These bits of Markdown are going to be for your reference mostly. So we can convert data manually, right? Up the top, we put a 5.0 to mean 5, or we had a 5 to mean integer. If we have just a 5 and we want it to become a float instead, we can pass in float. If we want to double check that that is in fact a float, you can do that by putting in type, float, and then the number. And we can turn a float to an integer. So 5.9, pass it to the integer function, and we're left with 5. And we can confirm that as well. Be aware, this did give us a 5, not a 6 from that integer function. 5.9 clearly rounds to 6, but that's not what the integer function is doing. We're not telling it to round, we're saying give us the integer value from what is presented. If instead we wanted to get 5.9 rounded to 6, we could use the round function. All right, so 5.9 rounded will give us 6. So some functions do take more than one argument. Round is one of them. We're going to see this in a minute. But how would we know it takes 2? Or how can we know what the round function does? Well, we can type in help and pass any function we want to it. Run that and it will tell us what it is. Round, here what it says is we can pass in a number, comma, n digits equals none. And what this means is that when we pass in a value like this, what we're doing is passing in a value for the number. If we don't pass in anything else, by default, this second argument, which says n digits, is equal to none. So if we leave it out, there will be 0 or none, the word none there, which means we are going to get back an integer. If instead we want to round to a certain number of decimal places, we can utilize this argument. So notice down here we have round again. We have our first argument. I put comma the number 3. So what this means is it's going to put the number 3 in for n digits. We'll run this, and now we have this rounded to 3 digits. If we want to round it to 1 digit, we can pass in the number 1. Now it's 5.9. So when we're rounding, we can go ahead and pass in multiple digits, but also, just as importantly, we can utilize the help function to understand what we can put into functions that we're actually trying to use. So another function we'll probably use quite often in here is ABS for the absolute value. And you can see here absolute value of -5 and 5 is both 5. We can pass in a float as well. We'll get out a float value. So I personally do not use scientific notation for much of anything, but if you need it, it is available and it's very easy to access. So all you need to do is say 5e to 1, 5e1 is going to give us 50. 5e5 is going to give us 50,000. If you count 1, 2, 3, 4, 5, there's your 5 zeros. 5e-1 is going to give you 0.5. So just by utilizing the e, Python knows that you're trying to use scientific notation. All right, so more for Python basics. What we're going to do here is look at literal constants, numbers, strings, and so on. So literal constants are going to be things that are viewed as a literal, right? We are literally going to use that value. So in other words, this is a literal. I am a string, or welcome to our new finance course. And we're going to go through examples of things. Numbers examples include integers and floating points. Strings include things within quotes. Okay, like we had above, we had the very first line, welcome to class. That is a string, which means it is text, and you could tell because it was wrapped in, again, as I mentioned above, single or double quotes. So let's go ahead and look at this. Just really quickly, here is a month name. We're going to save it as a string. I just want to show you how strings behave. We want to change that month name to January. we get an error. We're going to talk about why this is here in a moment, but I wanted to mostly demonstrate here, we've got a string, we've done something to it that's not allowed, we get errors, and you are going to get errors throughout your code nonstop. It's going to be in this notes, in the next notes, you're going to be every time you're doing an assignment and for the rest of your life. What we want to do is go here and see, how do we read an error message, right? They're not as scary as they might look. Obviously, a lot of this doesn't make any sense to us. So how can we understand what our problem is with the code so that you can fix it? Well, I always recommend skip to the bottom of the code. Okay, what this says is str object does not support item assignment. So we know we're doing something wrong. And we know up here it is likely taking place in this line of code. And obviously there's only one line of code in this cell, but it's very informative to us. We know what we're trying to do here is not available. String objects, so text, does not support item assignment. We're trying to assign a letter by this item. It doesn't matter if you understand what the code is doing. What you want to take away from this, and we'll see many other error messages, is jump to the last line. Don't try and read this up at the top. Don't try and read this long address. Don't try and read the comments or anything like that. Jump to the bottom, and this will be the most informative part of the code. Okay, so that's how we go about reading error messages. And what we're going to do here going forward is work with these different data types, interact with them. We're going to spend some time working with all three of these different things. Okay, so we want to talk a little bit more about comments, just some more details. So we've seen comments above, they've been very short, right? We're going to look at a few examples here. We've seen them like this. It's a comment, it's a single line, and it falls above code we want to execute. Down below, what we have is code where we have the comment to the right. Unlike above, we don't have it above the code, we have it to the right of the code, and that's completely fine. Where you choose to place your comment is up to you. And lastly, comments do not even need code to be there. You can have a cell with only comments, and that's perfectly reasonable. So the one fallback, or the one I think negative about using comments, is they are required to remain on one line. All right, so if I were to write a very long comment to continue this all the way on and go down, it would not continue. If I want to have comments spanning multiple lines, what I need to do is add a new hash on each line. So this is an example of a multi-line comment. I've hit enter myself. I've chosen where to go to the next line, and I've added my own hash. So just be aware of that. So the print function is one of them widely used functions. You'll use it all the time. You'll display things this way, and we can do a lot with the regards to how we format things. So understanding how print works is very important. So we have here, welcome to class, right? We're writing the word print, open and close parenthesis. And within that, you can see we have a message. And what we're going to do is display that message. We can, in fact, concatenate things together. So if we pass in January, 2021, we will get out exactly that, January 2021, separated by a space. We can concatenate two strings together. And what we get out is MSFT is the ticker of Microsoft. Continuing down, we can concatenate a variable and a string. So we haven't really spent much time or any time really looking at variables. And we'll spend some work on these throughout the next couple of lectures, but we're setting a variable. So stock name is equal to AAPL, the Apple ticker. And now we're going to do is print the variable name plus is the ticker of Apple. If we run this, what you get is AAPL is the stock ticker of Apple. So another common use of print is what's known as an F string. So notice here when we type print, what we have is the letter F, then some text, and then we place a bracket, a squiggly bracket. What this means is that it's going to print out and it's going to know whatever we place in here is a variable or a number or some unique formatting. So if we put stock ticker in there, it knows that we're actually referring to the variable stock ticker. We're not referring to just the string stock ticker. And what I mean is if we run this, you can see how it works. We get the correct output. If we were to remove those squiggly brackets and rerun this, now it just thinks stock ticker is a word rather than referencing a variable. So we need those squiggly brackets in the F to reference the variable. All right, and the last little bit right here with this print function is going to be now incorporating some different formatting. Okay, so let's say we have a stock price and it's got, I don't know, 7, 8, 9 decimals, whatever this is. We know that we're quoted in dollars, so we probably want 2 decimal places. Well, we can do percent formatting strings. So we have percent %s is currently trading at %.2f, and then another percent sign to end that out. And here in our set of parentheses, we have the word stock ticker and stock price. So when we run this, the first is substituted with stock ticker. The second is substituted with the stock price, where this one is going to be formatted as a string. This one's going to be formatted as a 2 decimal place float. So we can incorporate some different formatting with those as well. So just different variations on the print statement, ways we can kind of customize it to our needs in the different unique situations we're in. Okay, so let's spend some more time with the format function. So very similar, we're going to be formatting some output for print functions. We have a stock ticker this time and a price. And what we're going to do is look at a few different ways to use dot format. Notice there's no F here at the beginning. What we have is a print statement, and there's the end of our quote. Right, so there's the full thing. We are holding X in our portfolio, which has a price of Y. We say dot format, and we can pass in X equals and Y equals. When we run this, what will happen is X will be replaced here, the Y value will be replaced here, and we will print out that full thing. Now, if you don't want to use X and Y, we can in fact use numbers, placeholders. So we are interested in 0, which is currently trading at 1, where we're going to have the stock price and the stock ticker. So we're interested in Apple, which is currently trading at 212.12. And lastly, what we have is the ability to actually not even put in any placeholders there. So we have the squiggly brackets, both empty this time. And what Python will actually automatically do is replace the first squiggly bracket with the first value we're storing and the second squiggly bracket with the second value we're storing. And now what we see is we are interested in Apple, which is currently trading at 212. So lots of different options using this dot format. It's very powerful and allows us to print out some very nicely formatted output. So we need to talk about escape sequences next. And the reason why is you look down here, you can see the bold text. That's really easy. What if we wanted to print this out? Well, there are a couple of ways to do it. We could do something with double quotes. So let me add a cell here and actually show you. That's really easy. And there we have it. But what if we use single quotes? Can anybody spot the problem? So if we were to put single quotes here, and replace this. The issue is here's a single quote, here's a single quote, and here's a single quote. So we now have 3 single quotes. It's not clear to Python what's going on. We're going to get an error when we run this. Let's go back to double quotes and just leave it how it is. What you notice is that we can use single quotes still, but we have to include what is known as a escape character or an escape sequence. It is going to be this slash. So if we were to put this slash before the first single quote, it is letting Python know that we actually do want that single quote, the one in the middle of our sentence, to be displayed as a single quote. It's not part of the outside single quotes that are making this a string. Okay. So in other words, this allows us to use certain characters that may not otherwise be usable. We also have this ability to use this / to designate new lines. So right now, everything we've printed has been on one line. We can print out, this is really easy. /n, yes, it is really easy. What this is going to do, this /n, is it's going to result in a new line being printed. So if we go here, we run this, what we get is that is really easy. Yes, it is really easy, right? We've now printed this out onto 2 lines. Other things, maybe we need some spacing. Well, we can do /t, and what this will do is leave a tab in between them. So now 4 different tickers that were all right next to each other, tightly spaced, are a little bit more spaced out and easier to understand. And now what we want to look at is what happens if we have multiple lines of code or of print. Maybe this went too long, we couldn't read it, we want to do this. Well, if we break up a print statement onto 2 lines and run it, we get an error. However, if we include this / what happens is it now allows Python to know, okay, they're not done with this statement. It goes on to the next line, continue this being part of the print. And it's not going to put it on a new line. It's just more for you or I, so that we don't have giant long lines of code that nobody can read. And here what we want to do is talk about indentation. We haven't brought this up yet because we haven't indented anything. But in Python, indentation is incredibly important. It matters, and it will have an impact on how your code works. So this could, at first glance, look like correct code. Stock is Apple, print. Stock name is. But when you run it, we get an error. I've used a comment here to tell you why we got that error. Incorrect indentation, note a white space at the beginning, right? There is a white space there. It cannot be there. We need to remove all white spaces from the left-hand side. In other words, for correct indentation, unless we're in unique circumstances, which we'll talk about later in the class, you want everything to be left aligned. So just by removing that one white space, you can see now our code works as expected. So that was a brief overview of Python, of a Jupyter Notebook, and getting into it. We've got a couple more lectures in this first module of the course, so we will dive into 1.2 next, and I hope to see you there.